Hi, in this section we are going to practice some additional call option questions using the Black Scholes model. Now I've done some slight variations. This one is not that difficult in terms of the thought process. It's quite a straightforward question. And then there are additional questions where I've slightly introduced some basically introduced some additional concepts in order to make it a bit more difficult, in order to bring in some other concepts as well into the question, so that you'll become familiar with various types of questions that you could be asked in an exam setting. Now, the expectation is that most of the questions in the exam setting will be probably at a mid-level of difficulty, I would assume. And also based on my experience, I would say that it's very rarely you will get extremely difficult questions. But having said that, it's very difficult to predict the exact difficulty level of the question, and therefore it's always advisable to practice questions that makes you to think a bit beyond the usual memorizing a formula and plugging in some numbers to get an answer. And also, given that some of these concepts can be applied in your practical work experience as you start working in various divisions of a financial institution, it's quite important to understand the concepts and how to apply them. So let's go through this question. Now here we have been told that it's an European call option. It's an European call option. It's an European call option on stock XYZ. Has the current details. The stock is currently valued at $45. So that's my S naught is my $45. The strike price of the option is $50. So that's my K. The strike price is $50. The expected return of the stock is 4%. Time to maturity is 1 year. The stock has a daily volatility of 1.58%. The following, now here after this point here, we have been given some information on bonds. The following 1 year bond yields are observed in the market. Bond issued by XYZ, that's a company, with a maturity of 1 year has a yield of 9.5%. A government bond with 1 year to maturity has a yield of 8%. Assume there are 250 trading days in a year. Question is, what's the call option price as per the Black Scholes formula? Now, first thing first is that, of course, you need to remember the formulas of the Black Scholes model. Now, before that, let's calculate the D1 and D2. So D1, remember, according to the Black Scholes model, is log S naught divided by K. So that's the current price divided by strike, plus the risk-free rate, plus the square of your volatility or square of your standard deviation, divided by 2. You multiply the whole thing by time to maturity, and you divide this by the standard deviation times square root of t. So we simply plug in the numbers here. Now your stock is currently valued at $45, so that is 45, and your strike price is $50, so that's 50. Now let's look at the risk-free rate, because we are not directly being told what's the risk-free rate here. So the standard deviation, now remember, what's the call option price as per the Black Scholes Merton formula? The call option we are looking at is a 1 year call option. The stock is currently at 45. The strike price time to maturity is 1 year. So it's a 1 year call option. Now the volatility we have been given here is the stock has a daily volatility. We have been given a daily volatility. So we need to convert the daily volatility into an annual volatility because we are looking at 1 year. And we have been said, assume there are 250 days, trading days in a year. So we need to calculate the annual volatility before we can plug in that value here. So 1 year volatility, 1 year vol, just using shortened form, is 1.5811%. Now we don't multiply by 250, we multiply by the square root of 250 because we are calculating standard deviation of volatility. So that gives us 25%. That gives us 25%. So that's my volatility here. This is 25%. So 25% squared. T equals 1. T is 1. So that is my volatility is 25% times square root of 1. T is 1 because it's 1 year. Now, what is my risk-free rate of return? So here they have not given us the risk-free rate of return, but if you look carefully, we have been given the yield of two different bonds. One is a company called XYZ, which is a corporate bond. Now, because it's a corporate bond, that's what you can see. The yield on a corporate bond is slightly higher than a yield in the government bond. A government bond with 1 year to maturity has a yield of 8%. Reason the corporate bond has a higher yield is because if you invest in a corporate, you are taking a higher risk. So in order to compensate for a higher risk, they are giving you a higher return. Now remember, this interest rate is a risk-free rate. Risk-free rate. So the risk-free rate is same as a equivalent government bond, and we can use this 8%. And also you can see the government bond with 1 year to maturity. 1 year. So we are also looking at 1 year. This government bond also has a 1 year to maturity. So this is a good proxy or a good approximate. So in this case, my risk-free rate will be 8%. My risk-free rate will be 8%. 1 year to maturity has a yield of 8%. Now here we have not been told it is with continuous compounding, but for this question, let's assume that this is with continuous compounding. Continuous compounding. Now if it's not continuous compounding, I have another question. We'll go through that. You'll have to convert this into a continuous compounding rate. So let's assume that the yield is given based on a continuous compounding. So my yield is 8%. So that will help me to calculate my D1. That will help me to calculate my D1. My D1 will be 0.445. So remember some of the key things that we did here. We transformed the daily volatility into annual volatility. We transformed the daily volatility into an annual volatility by multiplying by square root of 250, which is 25%. And then the risk-free rate of return was not given directly. So what we did was we used the yield of the government bond. Remember, government bonds are always risk-free in that particular country. So we can use a government bond of 8%, and of course here we are assuming it's continuous compounding. If it's annual compounding, then we'll have to convert the annual compounding into a continuous compounding rate. So here we are assuming it's continuous compounding. We didn't use the yield on the corporate bond because that's not a risk-free rate. That's not a risk-free rate. So these are some of the key things that you need to understand and apply. And this is a bit more practical as well. If you're working in a financial institution into your option pricing model, these are, if you're using the Black Scholes model, in order to use your risk-free rate, you're going to use a particular risk-free instrument. It could be a government bond, it could be overnight rate, etc. So it's quite useful to understand it in this manner. So we have D1 0.445, and we can simply calculate D2. Remember, if you know D1, you can calculate D2 is simply D1 minus standard deviation times T. So that gives us, you simply use your D1, which is 0.445, and you have your standard deviation and your T. Remember, your standard deviation is 25%. So that gives us a D2 of 0.195. Once you have your D1 and D2, you can calculate your N D1 and your N D2. Simply the cumulative distribution tables. From your cumulative distribution tables, you can calculate them. So you get 0.67184 and 0.577303. Now the best way to find these values, if you're using the Z table, you'll have something like this. When you use the Z table, for example, if you want to find D1 0.445, you'll have 0.4 here, and let's assume you have 0.04 here, so that's 0.44. Somewhere here where these two meets, you'll have 0.67, etc. Now for this one, 0.195, so you have 0.1 here, and 0.09 will be here, so 0.19, you'll find this value here, which will be 0.57. Now here you see a bit more detail because I used Excel to calculate the value. So Excel goes beyond 2 decimals and calculates the perfect value. Now when you're using a cumulative distribution table, you are slightly limited, but you'll get closer to these values. So that's ND1 and that's ND2. So once you have your ND1 and ND2, you simply use your European call option formula according to the Black Scholes model, which is, remember we discussed this, the best way to remember the formula, the payoff is simply S0 minus strike discounted. So today's value means today's stock price S0, and European call option can only be exercised at maturity. So today's value, today's exercise price is the exponent of, you discount your strike to today minus risk-free rate times time to maturity. So that's your payoff today, and then you include your probability values, which is ND1 and ND2. So you can start with the most basic ones. Today's stock price minus strike discounted at the risk-free rate of return using compounding risk-free rate of return, and then ND1 and ND2. So that gives you a call option price of 2.77843. So remember what we did here when we tried to calculate the call option price, we had to do few small observations. The daily volatility has to be transformed into an annual volatility. We did that here. We found the risk-free rate of return using the government bond yield. That's here. And once we do those two, you can calculate the D1 and D2. And I also showed you, if you're using a cumulative distribution table, how you can calculate, find the ND1, ND2 simply by using this. So that's ND1 and that's your ND2, and then you plug in those values into your call option formula, and that gives you the call option price. Now the next question, so for the I'll stop with this one for you to have a look at this. Now in my course I'm going through some of the detailed questions such as these ones. The videos I'll be doing, I'll try to avoid the ones which are very straightforward, such as you're just been given the stock price, the strike price, and also the variables that you need to calculate, the ND1, ND2. You calculate them and then you plug it into a formula and then you get your call option price. I will try to avoid those questions in my lesson, in my video lesson. You'll have some of them to practice part of the question answers that I've been attaching on the sessions. But in terms of the videos, I'll probably touch on the ones which will require you to think a bit more in terms of how some of these variables can be slightly twisted in order to make you to think, and also some of them are more real world scenarios as well. Those ones, I believe that it'll be much more useful for you to understand the concept and be ready for the exam.